In this video, we're going to be working out a couple static electricity problems that are focused on the conservation of charge and then also using Coulomb's law as well. So we have the first scenario where 500,000 electrons are gained by a balloon that was rubbed on a sweater. And we're looking for what is the charge of the balloon and what is the force between these objects after their interaction if their separation is 50 centimeters. Now, the first thing you do is go ahead and sketch out a little picture. So we have a balloon and we also have a sweater. And the balloon being more of an insulated material, so if you rub these two together, it will be the one that gains electrons, and then in the end, it will have a surplus of 500,000 electrons. Now, because of the conservation of charge, the overall amount of charge between these two objects is going to remain consistent. So for this one, it originally had a fairly even mix of positives and negatives, and because a bunch of its negatives were given over to the balloon, this one is mostly positively charged. So we can go ahead and use the formula Q equals NE, where Q is the net charge, and then N is the number of electrons, and then E is the charge of an electron, which is a constant, negative 1.6 times 10 to the negative 19th coulombs. So the calculation is fairly simple. If we want the net charge of the balloon, all we do is take the amount that it gained, multiply it by the single charge of an electron, and then we have our answer. Now what I'm going to do is I'm actually going to go down to number 2 and complete number 2, and then actually come back and finish up the rest of number 1, because number 1 has a bunch more details on it that I want to cover. So for number 2, it's closely connected to what I have in orange over here, so I'm going to continue with this process. So it's still Q equals NE for this one, except the person loses 50 million electrons. So I'm going to put minus 5 times 10 to the 7th, or I could put all those zeros in there, but I'll just keep it in scientific notation. Because it loses electrons, we're going to make sure we put the negative in front of it, and then again put that constant 1.6 times 10 to the negative 19th coulombs, charge of an electron, multiply the two, and then I'm going to get a positive net charge of 8 times 10 to the negative 12 coulombs. So both of the calculations are fairly simple. If you want to solve for any of the variables, which would basically either be your N value or your Q value, you can just go ahead and use this formula. Your lowercase e is going to be constant, so you won't be solving for that. Now, taking a look at number 1, we want to use Coulomb's law in order to figure out the force between them, and that would require us to have 2 different Q values and a separation distance. So we are going to the separation distance of 50 centimeters, divide that by 100, and then call the R value, our separation distance, 0.5 meters after we divide this by 100. Now the thing is, we also want the Q value for the balloon and the sweater. So we do have the Q value of the balloon, but we do not have it for the sweater. Turns out that because of the conservation of charge, if this one gains 500,000 electrons, that means this one loses 500,000 electrons. So the sweater will have the same charge as the balloon, except it will be a positive number. So when we do F equals KQQ or Q1 Q2 over R squared, we have a Q1 value of negative 8 times 10 to the negative 14th for the balloon. And then we would have positive 8 times 10 to the negative 14th coulombs for the sweater. Now, because we're just going to find the magnitude of the force, we're going to go ahead and drop the negative sign. So our Q values would actually be the same if we're just taking a look at the magnitude. So we can go ahead and take the force as the constant K, 9 times 10 to the ninth. Take 8 times 10 to the negative 14th. And because both of them have the same magnitude of charge, we'll just go ahead and square that. And then our separation distance is always squared. And then that would leave us with a final answer of 2.30 times 10 to the negative 16th newtons. So to sum things up, when you want to find the amount of charge with an object, depending on how many electrons it gained or lost, you're going to do calculations like I did in orange over here. And then due to the conservation of charge, if you know the separation distance between two objects that were charged from one another, you can go ahead and use Coulomb's law because their Q1 and Q2 are going to be equal but opposite signed charges, such as our balloon and our sweater in this one. Now, in a final situation, where it might tell you the amount of electrons and protons, you can use a formula that looks like this, which is basically taking the number of electrons, subtracting the number of protons, and then multiplying that by negative 1.6 times 10 to the negative 19th coulombs. And then that will work as well to find your net charge. We didn't happen to have a problem like that, but if you're given both of those numbers, you can go ahead and subtract them, find the difference between them, multiply that by that Q value of an electron, and then you can get your net charge that way. So I hope that was helpful to you in solving some different electrostatic questions. Thank you for watching and listening.